Hello everybody and welcome to Chapter 3, Section 4, Graphing Quadratic Functions in Vertex Form. Our essential question is, how can you describe the graph of a quadratic function in vertex form? F of x equals a times x minus h to the power of 2 plus k. What we're going to learn is how to graph quadratic functions in this form. Now, this form should be looking very familiar and have the same variables that we've seen before, because we have seen them before in our absolute value functions. So vertex form is fun because whatever the values of h and k are will tell us what is the location of our vertex, which in this case h and k are both 0, so our vertex is at 0, 0. If I move the value of h, remember that h is the horizontal shift, so it changes the values horizontally, so it moves it left and right. In the function, if we look at our equation at the top left, we have a positive 6 here as h, but in the function, it is a negative 6. Okay, so that's what we have to remember from our function, is that whatever is inside the parentheses is going to be the opposite of what we're looking at in the function. K shifts the graph up and down. Notice how that does not change our axis of symmetry at all. And our a value does not change the axis of symmetry at all. It just makes the graph wider and more narrow, or stretch and shrink. And also, if it's negative, it'll flip the graph over to the other side, okay, just as we've expected from before. Okay, notice how whatever my h value is, that's also where the axis of symmetry is, and that's what makes this form very easy to graph, because we already know our axis of symmetry as well as our vertex based on what is h and what is k. So for example number 1, we're going to be graphing this quadratic function g of x equals negative 2x plus 2 to the power of 2 plus 3. So this one's actually fairly simple. What we're going to do is I'm going to show you our form, or vertex form, which is ax minus h to the power of 2 plus k. I'm going to also write our function that we have here, right down here, which is negative 2x plus 2 to the power of 2 plus 3. Okay, so for our axis of symmetry, we're going to take whatever the value of h is, right? That's what we have right here. Axis of symmetry, x is equal to h. So check out how this 2 is in the position of our h, but remember we said that we want to take the opposite of what that number's sign is from the function to get our axis of symmetry. So we have an axis of symmetry of negative 2. All right, so I'm going to go ahead and draw that onto our graph over here. I would need a vertical line passing through the x-axis at negative 2. And then our vertex is located at the point hk. H comma k, we have our h, which is negative 2, and our k is positive 3. So we have a vertex located at negative 2, positive 3. So I'm going to place a point there, negative 2, positive 3. It should be on our axis of symmetry. There we go. All right, so unlike our standard form function, this function doesn't tell us anything else that we can graph. So what we're going to need to do is we're going to need to solve for 2 other values. So what I'm going to do is I'm going to, actually, before I do that, I'm going to move my axis of symmetry up a little bit so I can have some space, because I'm going to need to solve equals negative 2, and then our vertex is negative 2, positive 3. Okay, we got that. All right, so what I'm going to need to do here is I'm going to go ahead and pick some numbers that I'm going to substitute so that I can graph them on the graph. So I can find my nice little curve. This is plus 2. All right, so then what I'm going to do here is I'm going to take the x values, and I can pick any x number that I want, but I want to keep it close to my axis of symmetry, because this is quadratics. Numbers can grow very, very fast because of the exponent. So I want something that's very close to this negative 2. So I'm going to pick numbers to the left or to the right. So What I'm going to start off with first is I'm going to replace this x with the number right to the right of this negative 2, which is a negative 1. Okay, so that's what I'm going to do right there. Then I'm going to begin to solve it. So what I want to do here first is the parentheses. Okay, parentheses goes first. Okay, not the exponent, leave the exponent still. So that's going to be negative 1 plus 2, which is a 2. Oh, a 1, I'm sorry. Everything else is going to come right down, including our exponent. All right, after parentheses, we do exponents. So I'm going to do this, 1 to the power of 2, which is 1 times 1. Everything comes down that I didn't use. Then I'm going to multiply negative 2 times positive 1. I'm going to bring down my 3. And then that's going to result in a positive 1. All right, so our first point is I substituted a negative 1, so that's the number I chose, and then I ended up with a 1. So I'm going to go to negative 1, positive 1, so that's going to be right here. And because parabolas are symmetric, I'm going to have another point that's the same distance away from our axis of symmetry on the left side. So this helps us so that we don't have to solve the function that many times. All right, so I'm going to go ahead and do this one more time. I'm going to need at least 5 points on this particular type because we need a nice shape. So I'm going to do g of something negative 2 blank plus 2 to the power of 2 plus 3. Okay, so I'm going to choose a different number now. So I'm going to choose one more to the right of this, so that would be 0. So I'm just picking the numbers that are to the right of the axis of symmetry. So I'm going to 0. Parentheses goes first. 0 plus 2 is 2. Everything else comes down, negative 2, power of 2, plus 3. So then I do the exponent. 2 to the power of 2 is 2 times 2, which is 4. Everything else I bring down. Multiply. Negative 2 times 4 is negative 8. Bring down the 3, which is negative 5. All right, so our next point is 0, negative 5. So I'm going to go from 0, and I'm going to put a point on negative 5. I'm going to also reflect this point across the x-axis, across the axis of symmetry, because parabolas are symmetric. And there I have my shape of my U. Now I just have to kind of put it together. So I'm going to change my color just so you can see the points clearly. I'm going to try my best, not to use the line tool, to use the pencil tool, and to kind of draw a U-like shape. And it is okay if it's not that good of a shape. As long as it looks like a U and not a V, I think you're going to be okay. All right, so this is how you graph a function in vertex form. Find the axis of symmetry, find the vertex, choose 2 numbers, any x values, to find 2 other points on the graph, and then you're going to reflect those across the axis of symmetry so you can get a total of 5 points, and then draw your curve. All right, that is the end of our lesson. All you've learned in this lesson is how to graph a quadratic function in vertex form. If you have any questions, comments, or concerns, please feel free to leave them in the comment section down below. Thanks for watching. See you next time.